Radio waves can be used to send signals between two areals. How this happens is a somewhat complicated process, which will touch on some ideas you won't see elsewhere at GCSE, but it's the process you may be asked to describe in your exam. So let's go through this step by step with the key details an examiner would be looking for. In the first step, an alternating current causes electrons to move up and down the transmitting aerial. Here's an example of a radio transmission aerial, which we send an alternating current into. The alternating current, or AC for short, transfers electrical energy by making delocalized electrons move back and forth in a conductor. There is also a conductor inside the aerial, which also has delocalized electrons. These electrons will move up and down as they're pushed and pulled by the alternating current. In step 2, the oscillation of the electrons produces an electromagnetic wave of the same frequency. An electromagnetic wave is a special type of transverse wave, which can travel without matter. Instead, it travels as oscillations between an electric field and a perpendicular magnetic field. Now, you don't need to know exactly how the oscillating electron does this. At GCSE, you don't really need to know that there's some link between electromagnetic waves and these types of fields, even though the clue's in the name. In an exam, you can just say that the oscillations of the electrons produce an electromagnetic wave and then leave it at that. A detail you do need to know about, though, is that the frequency of this wave will be the same as the current. So if we send a 50 kHz current to the aerial, then that will produce a 50 kHz wave. Each oscillation of the electrons will produce one wavelength in the wave. This is also why we produce radio waves in particular, since they have the lowest frequency of all electromagnetic waves. It's hard to produce alternating currents with large enough frequencies for other types of waves. In step 3, the electromagnetic wave travels to a receiving aerial. Here's an example of a receiving aerial. It looks very similar to the transmitting aerial. We want to have it aligned so it's at the same angle as the transmitting aerial, though more specifically, we align it to the oscillations in the electric field. The radio wave then transfers the energy from the alternating current in the transmitting aerial to the receiving aerial. In step 4, the wave causes electrons in the receiving aerial to oscillate with the same frequency. Again, you don't really need to know why this happens, but similar to how the oscillations of electrons cause the wave to oscillate, the oscillations of the wave cause electrons to oscillate in the receiving aerial. Then in step 5, this produces an alternating current, which carries energy and information. This current happens because electrons in the receiving aerial are oscillating, just like they are in the transmitting aerial. Again, like how the frequency of the wave is determined by the frequency of the transmitting current, the frequency of the receiving current is determined by the frequency of the wave. So since we used a 50 kHz current in the transmitting aerial, we received the same 50 kHz current in the receiving aerial. But how does this send a signal and not just energy? Well, we can use varying frequencies and amplitudes in the waves to change the signal. Computers and speakers can then translate these signals into messages.
Thanks for watching. If you want to take your GCSE revision to the next level, head over to launchpadlearning.com and check out our smart learning platform that's been designed to get you top results in your exams. We cover your whole specification and make revision fun with interactive quizzes, easy-to-follow videos, and more. You'll be kept motivated by your own AI tutor who's here to support you every step of the way. To check it out for yourself, click here. Or click here to keep watching a selection of the videos from our full GCSE Physics course. See you there!